Welcome to this video on the topic of multiplication and division with algebraic fractions. In this video I'm going to show you 4 examples of how we go about doing multiplication and how we go about doing division when we have fractions involved. Now, example 1, we're dealing with 2 fractions and we want to multiply them together. Looking at our rule over here, what we do is we look at the 2 numerators when we multiply, and we multiply these 2 together, and then we look at the 2 denominators and we multiply those together. So applying this rule for example 1, we've got 4 over s times s over 12. We're going to go 4 times s, and then we're going to go s times 12. Now, if we wanted to, we could simply use our algebraic rules and clean this up so it would become 4s over 12s. But that wouldn't be the simplest answer we could arrange it at. Rather, what we're going to do is we're going to break these down, or break this answer so far down into its factors, and then we're going to simplify. So breaking this down, we'll start off with the denominator, and we're going to say, well, there's an s, and it's going to be times. And if we look up in our numerator here, we've got a 4 here. So we ask ourselves, is there a factor for 4 inside 12? And the answer is yes. If we break 12 down, we get 4 times 3. So that's our 12, and here's also our 12. Alright, now dealing with the numerator, we're not going to do a whole lot. We're simply just going to go s times 4, like so. Now, we look at what's common between the two, and we can see an s over here, and we see an s over here. And we see a 4 here, and we see a 4 here. So everything highlighted in green is going to go away. So what that's going to leave us is a 3 down in the denominator and a 1 upstairs in the numerator, and that will be our result. 4 over s times s over 12 is equal to 1/3. Going down, we have 2 over r times r cubed. We want to multiply these together. Now, first problem we find is that, well, this second factor, it's not a fraction, but rather it's simply apparently a whole number. But what we can infer is that, well, if there's an r cubed, then if it's like that, it's always going to be over 1. Now, with that in mind, what we can do is we can multiply the 2 numerators together, and then we multiply the 2 denominators together. So that's going to give us 2r cubed all over r. Now simplifying, if you think about this r cubed up here, think of the factors, and the factors of r cubed are going to be r, or 2 times r times r times r all over r. Looking at what's common, we've got a single r here and a single r here. They're going to cancel each other out, so it's going to become 2 times r all over 1, and that's the same as writing 2r squared. Too easy. Alright, let's go down and do some division examples. So in example 3, we've got 4 over x divided by 12 over x squared. Now, from the last video, we know that the rule involving division is we first turn the problem from a division problem into a times problem, and then multiply it out. Now, to turn it into a times problem, what we have to do is we have to look at our second factor here, and we're going to flip the fraction about. So what that means is we're going to get a 4 over x, so that's unchanged. We change our division to a times, and then we turn this denominator upstairs and the original numerator downstairs. Alright, now that we've got a timesing problem, we multiply the numerators together, multiply the denominators together. That's going to give us 4x squared all over 12x. Alright, now we could go for the step where we factorize everything and cancel them out, but let's have a go at doing it simply by looking at it. We ask ourselves, is there anything common between 4 and 12? And the answer is yes. If we divide 12 by 4, we're going to get 3. So if we divide both the numerator and the denominator by 4, we're going to simplify. So we can go 1x squared all over 3x. Now, simplifying again because we have these x's, if we want to deal with the x squared over the x, we can cancel the x out with the x squared, and we're going to go 1x over 3. And of course, we don't need that 1 in front of the x because it's an implied one. So we can go x over 3. So that's our final result there. 4 over x divided by 12 over x squared is equal to x over 3. Alright, let's go down to our fourth and final example. We have 6 over z all divided by 2. Now once again, we're dealing with a factor that's not actually a fraction, but it's an implied fraction, and that we can put it over 1. Now, the way in which we're going to deal with this is we look at our second fraction, or second factor, and we're going to flip it about to change this divide into a times. So that's going to yield 6 over z, then we change divide to times, and then we flip everything about in the second fraction, so it becomes 1 over 2. Now, multiplying everything out, we go 6 times 1, that's 6, and then we're going to go z times 2, and that's going to be 2z. Simplifying this out, 6 over 2 is going to be equal to 3 over 1, like so, and we don't need that 1 in front of the variable because it's implied, so we can go 3 over z. So our answer to 6 over z divided by 2 over 1 is equal to 3 over z. Too simple. Alright, so that concludes our 4 examples.